Okay, so we're doing 4.6, the second half of the lesson. This is the parent graph that you have memorized, hopefully at this point. Not each point, just the basic behavior. They approach the asymptotes in the first and third quadrants of asymptotes at x equals 0 and y equals 0. So if you had to guess, what do you think would happen? And you know a little bit about function transformations. What would happen if we add 2 at the end of the function? My guess is that you would guess that the horizontal asymptote would move up 2 units. So now it would be y equals 2. In other words, this thing is going to move it up because after the function, and then you're still going to have a vertical asymptote at x equals 0. And this would be a good idea if you want to, like if you want to get the intercepts correct. I don't think we have a y-intercept, but I think we would have some x-intercepts. So to find x-intercepts, you plug in y equals 0. So if you do that, you would get, let's see what you get. So 0 equals 1 over x plus 2. Subtract 2, you get negative 2 equals 1 over x. Multiply by x, you get negative 2x equals 1. Divide by negative 2, x equals negative 1/2. Okay, so right about here is an x-intercept. Right away, I know what's happening on the left-hand side, right? The graph's going to look like this. It's got to go through that point, kind of approach the asymptote. It's not going straight down. It's going closer and closer to that axis there, to that asymptote. And on the right side, it either does this or this, and it really can't do the second one because it would have to cross the x-axis. The only place to cross the x-axis is negative 1/2. So it's got to be up there. That's your graph. Again, I'm not worried about each individual point, just the behavior. Actually, I really didn't even have to do that, right? Think about it. It's just taking this function, moved it up 2, just took that whole function, moved it up 2 units, and so you know what that's going to look like. I guess I'm just, thinking back to, uh, some other functions we've done. Okay, negative in front. What do you think a negative in front of this function will do? Remember, the original function kind of has this kind of a look to it. So normally, a negative in front reflects over the x-axis. I think that's exactly what's going to happen. So you're going to reflect over the x-axis this way, and this one from the bottom left is going to reflect up this way. And again, you're going to have an asymptote still at x equals 0. That won't change with the reflection, and an asymptote horizontally at y equals 0. This one, you might have a guess what this one does. So it's kind of interesting. Think of this as inside the parentheses. Now, the parentheses are in the denominator in this case. Inside the parentheses, so this would be, let's see, it's going to move it not to the right where you might think. It actually always goes to the left. It goes the opposite of what you think. In this case, it goes to the left. So my vertical asymptote now is going to be at x equals negative 2. My horizontal asymptote moving left doesn't change, so it's still y equals 0. And the graph, definitely this quadrant. It's not a bad idea to figure out what the y-intercept would be. It's pretty easy to do that. Plug in 0 for x, so 1/2. So I think it is going to cross right about there. This graph will look something like that. I do like to find the intercepts, even when I'm doing transformations, but basically everything shifted 2 units to the left. Every point shifted there. Let's do this 2 different ways. So we're going to do this the way we just learned, which is transformations. We're going to solve this, and then we'll solve it another way, I think. Actually, this way, oh, I can't do this one doing the other way, actually. I just thought about that. Oh, well. I'll change it slightly. Okay, it's because I have this -2, and we're just solving rational functions, really, in this chapter. So this does a number of things. So if you think about the parent graph, this negative in front of the function, essentially, is going to reflect it over the x-axis. So instead of being in the first and third quadrants, it's going to be in the second and fourth quadrants, something like that. And then the -3 is going to move it to the right 3. So the new asymptote will be, instead of vertical asymptote, so x equals, and is going to be x equals 3, instead of x equals 0. So x equals 3. And the new y-intercept, it looks like it's going down 2, so it's going to be y equals -2. Barely fit that y equals -2. And so our graph is going to be, well, it's not a bad idea. At least let's find the y-intercept. So if I plug in 0, that's negative. It's 1/3 minus 2, which is like, I don't know, negative 1 2/3, somewhere around there. The x-intercept, plug in 0 for y. So if you do that, you end up getting 2 equals -1 over x minus 3. Multiply by that, divide by that, you get x minus 3 equals -1/2. So you get x equals 3 plus -1/2, or 2.5, I think. So 2.5-ish, right about there. So the graph here looks something like this. And on the right has two choices. Either the graph does this, which it can't do because it doesn't cross the x-axis anywhere else. Oops. Or it goes down here, and that's exactly what it's going to do. Let's go down here. And so I've got my graph. So the only thing about this one, I guess I should have done one where it just does. I added a little too much with this. Using our methods, we can solve, I think we could solve this one, right? So the only thing to be different about this graph is it won't be moving down to, but everything else, should reflect, should do all that other stuff. So if we graphed it this other way of doing it, we'd look at the denominator and go, okay, where's the vertical asymptote? It's right there, x equals 3. And where's the horizontal asymptote? It's bottom heavy, so there's a horizontal asymptote at y equals 0. The reason it's not at the same place as the one on the left is because that one moved everything down too, so their asymptote is down too on that one. And the intercepts, y-intercept would be, if you plug in 0 for x, it's positive 1/3. We're about there. And the x-intercept, I doubt there is one. Well, let's see. Ooh, this is interesting. So if you plug in y equals 0, you end up getting you get 0 equals -1, which doesn't work. Okay, so there's no x-intercept, and there's an asymptote there, so that actually makes sense. So it still has this behavior. Again, this one's not moved down to. I don't have enough information to know for sure here, unless you know something about the reciprocal function, which we do, which means it's going to be in the opposite quadrant there. So you could plot a point here. So sometimes it's good to plot a point. Let's just show you how to do that. So if you plug in, say, x is 4, what is the corresponding y value? So that would be -1 over 1, which is -1. So 4, -1 is right about there. So I know the graph goes through that point. So it kind of looks like that. It's kind of contained within those asymptotes. So those are the kinds of transformations. You could do some problems. You might have a choice. You could kind of do it this way on the right, or you could kind of do it maybe on the problems on the left using the reciprocal function transformations. So this is just kind of like an extra twist. There's one other thing I wanted to mention to you, just because on a really tough problem, this can happen. Vertical asymptotes, if you have, let's say you have 2 vertical asymptotes for a problem and 1 horizontal asymptote. So one thing I didn't mention about vertical asymptotes is they're strong. They can never be broken. The graph cannot at any point cross through there. Not going to happen. It's not even going to touch a vertical asymptote. They're so strong. But horizontal asymptotes are weak, especially in the middle. Towards the end, like typically, towards infinity and towards negative infinity, these are going to approach the asymptote. In the middle, a horizontal asymptote can be kind of weak. In other words, you might expect maybe the middle to do this, or do this, and those be the only choices for the middle there. But actually, weird stuff happens. Sometimes the graph will do stuff like this. It'll actually cross through a horizontal asymptote in the middle. That can happen. So you have to be very careful, especially if there's two asymptotes in the middle. And that middle area is the place you really have to be careful, especially with horizontal asymptotes. Vertical asymptotes are super strong. They'll never be broken. You can't touch them. But horizontal asymptotes, especially in the middle of a graph, not towards infinity or negative infinity, can be kind of weak. So keep that in mind.